Hello, I'm Shawn Riley, Chief Data Officer and Chief Information Security Officer at DarkLight. Today I'd like to talk to you about artificial intelligence, and I'd like to start off with a formal definition before getting into a more general discussion about the different fields of artificial intelligence that we're seeing applied within the cybersecurity ecosystem. So, in computer science, artificial intelligence, sometimes called machine intelligence, is intelligence demonstrated by machines, in contrast to the natural intelligence displayed by humans and other animals. Intelligence is the ability to acquire and apply knowledge and skills. Artificial intelligence uses inference, which is a conclusion reached on the basis of evidence and reasoning. Data science-derived AI uses inductive inference and probabilistic reasoning. Knowledge engineering-derived AI uses deductive inference and contextual reasoning. So let's look at the two main fields of artificial intelligence that we see being applied. And let's start off with the most common one that we hear about, which is data science-derived AI, such as machine learning and deep learning. So the focus of data science-derived AI is on the patterns in the data set or data silo that it is applied on to tell us about the patterns, right? And the patterns are kind of used for classification, for clustering, or for making predictions about threats and risks within the ecosystem. Data science-derived AI takes a statistical approach and uses bottom-up methods to tell us about the data. And so when we think about data science-derived AI in technology within the ecosystem, you kind of have two different approaches. You have kind of data science at the edge, which is a great example looking at things like antivirus or intrusion detection, where the machine learning is right there coupled with the sensor looking at the data and then making predictions based on the patterns that it's seeing off of that sensor. The other way that we see data science-derived AI applied within the cybersecurity ecosystem is by kind of centrally locating your data and then applying the analytics on it at that point. So things like a security information event management system that's machine learning based is going to be a central repository of all those logs and events coming in and applying the machine learning on that to do the classification, clustering, and predictions. You also see that kind of centralized approach with network traffic analysis, where you might have data coming in from multiple network sensors and then a central location where you're doing all the kind of analytics and machine learning. Knowledge engineering derived AI has a very different focus. It doesn't compete with the data science derived AI. They're not trying to solve the same problems. Knowledge engineering derived AI focuses on mimicking the human domain expert's experience and skills in applying the knowledge to solve problems. So when you think about knowledge engineering, it's really focused in on being able to take information from a number of different sources and integrating that together into integrated knowledge. So you might want to integrate, say, your business knowledge with your cybersecurity operational knowledge. So maybe past incidents and your asset status of authorized devices and software and things like that. That type of organizational knowledge, and you might want to fuse that with your business knowledge, such as what parts of the business or mission does different assets support. And then you might also want to integrate external knowledge that's relevant to the things that you're doing within cybersecurity or within the domain that artificial intelligence is working in this case, cyber defense. So you might want to pull in things like external knowledge, like MITRE's attack knowledge for adversary tactics and techniques, or the ODNI cyber threat framework, or the NSA technical cyber threat framework that really focuses in on the stages of the cyber attack lifecycle and the objectives of the adversary, along with what actions align to what objectives and what are the indicators for different actions. Those are kind of examples of external knowledge that can be captured as a knowledge model and you can capture the experience or the skills of the human expert in applying that knowledge in a cognitive playbook. So knowledge engineering derived AI takes a logical approach and top-down methods where it's going to take this knowledge and apply it into the situation or the investigation that you're looking at. So very different approaches. Data science derived AI takes a statistical approach where the results are kind of probabilities, and knowledge engineering derived AI takes a logical approach. So we kind of describe the two main different fields. Let's look at some characteristics and kind of hard problems within those. So when we think about knowledge engineering derived AI, it's 100% transparent and explainable. So knowledge engineering is really taking and building symbolic AI, and symbolic just means human readable AI, because what we're doing is we're taking all the human readable knowledge and integrating that together, and the experience of human experts in applying that knowledge that's captured in these cognitive playbooks. So each of the cognitive playbooks is kind of a series of steps in a workflow that includes reasoning and inference. Basically, it's saying, hey, I want to grab this data and I want to apply this contextual reasoning to it. And once I find the facts in the situation, then I can start making inferences based on those facts using deductive reasoning, where I can deduce facts out of my knowledge into that particular investigation. When we think about the data science side, the conclusions of the reasoning, as we mentioned, are probable, and this is because it's using inductive inference, and inductive inference doesn't have to be right, it's just the best guess. And so one of the other challenges that we have with the data science derived AI is that it can't yet explain how it arrived at the conclusion that it's arrived at. So it's hard to build trust in something that isn't explainable. And when we think about trust, one of the big themes at RSA this year was zero trust and zero trust architectures. And when you think about zero trust, since the results of data science derived AI, such as machine learning and deep learning, are only probable, in other words, they're just conjecture at the moment because they're a best guess, they all need to be verified before you make a decision and take action. And when we think about another kind of hard problem is the reproducibility of results. And the BBC a couple months ago had an article on the reproducibility crisis within science, and it's from, most of the fields of science are using both data science and knowledge engineering. On the data science side, a lot of the machine learning techniques used by thousands of scientists to analyze data are producing results that are misleading or often completely wrong, according to the article that I read. And a lot of this has to do with some of the bleed through from the kind of modeling process, and where you're not actually getting the data in the result, but actually getting kind of the data in part of the model in the result. And so when people go to reproduce that, they're not getting the same results. In order to kind of combat that, the knowledge engineering side has really focused in on making sure that it supports reproducibility. And what I mean by that is that the knowledge models are W3C standards-based OWL, ontological web language, OWL, knowledge representation languages, which means that all the kind of knowledge engineering based derived AI is going to be able to use these standards-based ontological knowledge models. The other thing that's important for reproducibility is that ability to capture the skills of the human analyst in a reproducible way for how they apply that knowledge that's captured in those knowledge models. And that's why we created these cognitive playbooks. And we really modeled these after the DHS and NSA sponsored integrated adaptive cyber defense framework, where they're building mechanistic action frameworks for the orchestrators to take different actions we build shareable cognitive playbooks that capture the skills of the human analyst that are importable and exportable so they can be shared along with the knowledge models and the mapping of the raw data to the knowledge models. And that really supports kind of a couple things. It supports peer review, so you can exchange your knowledge models along with your cognitive playbooks with other organizations or other analysts within your same organization for peer review. It also supports reproducibility. Hey, this is the experiment that I did, or these are the results I got. This is the knowledge model that I used, and this is the cognitive playbook I used. This is the mapping of the raw data to the knowledge model. Let me share all of that with you and see if you can reproduce the results with your data. So it's a great way of solving the kind of reproducibility crisis by applying knowledge engineering derived AI to then validate the results or verify the results coming from data science derived AI. So, and that's it. That's kind of our quick overview of artificial intelligence. We talked about the formal definition. We talked about the two primary types or fields of artificial intelligence that are being applied within the cyber ecosystem today. Data science derived AI, such as machine learning and deep learning, where the results are probable and it's still yet unexplainable and has problems with reproducibility within a zero trust environment. Data science derived AI requires verification, so that way you can verify the result before you make a decision and take action. And we talked about knowledge engineering derived AI that focuses on mimicking the human analyst or the human expert experience and skills of that domain expert in solving problems. Till next time, take care.